Welcome to BuildBytesDaily. This is the channel where we take those really complex dev topics and break them down into easy-to-digest bites. Today, we're diving into something that honestly trips up developers at all levels, the JavaScript Event Loop. If you've ever stared at your code and wondered, how on earth is JavaScript handling my clicks and fetching data without just freezing up? Well, you've come to the right place. All right, let's get right into the heart of the problem. Here's the deal with JavaScript. At its core, it is single-threaded. That means it can only do one thing at one time, period. But then you see code like this, setTimeout. It's telling the browser, hey, wait 3 seconds, then do this. So if JavaScript can only focus on one task, shouldn't waiting for that timer completely lock up your browser, right? You shouldn't be able to scroll or click anything. But you can. So what is this magic? That's the puzzle we're going to solve today.
So here's how we're going to do it. First, we'll look at what I call the one-lane highway problem. Then, we're going to meet JavaScript's hidden teammates. After that, we'll trace the great handoff of an async call, see how all this keeps your UI rendering buttery smooth, and finally, we'll put it all together.
Okay, let's start with the root of this whole thing. I want you to think of JavaScript's single thread as a one-lane highway. There's only one lane, so only one car can go through at a time, and if one car breaks down, well, you get a massive traffic jam.
So what do we actually mean by single-threaded? In programming terms, it means JavaScript has just one call stack. And that call stack, that is our one-lane highway. It's basically a to-do list that keeps track of which function is currently running. One stack means one lane of traffic, and only one function can be at the front of the line at any given moment.
Let's see it in action. Okay, so our code starts running, and boom, main gets pushed onto the stack. Then main calls print square, so that gets added on top. Print square calls square, which goes on top of that. And then square calls multiply. You see how they're stacking up? Now, once multiply is done, it gets popped off the top. Then square finishes, and it gets popped off. This goes on and on until the stack is totally empty. It's what we call last in, first out. Simple, synchronous, one at a time. And here, this is the big problem. What if one of those functions on the stack is super slow? What if it's doing a massive calculation? It blocks the entire highway. The browser's just stuck. As long as that slow function is sitting on the call stack, the browser can't do a single other thing. It can't repaint the screen, it can't respond to you clicking a button, nothing. The result? That frozen, unresponsive page that we all hate. So you have to be asking, if the call stack is so easy to block, how does anything in the modern web even work? Well, here's the secret. The JavaScript engine, like Chrome's V8, it's not working alone. It's got a whole team of hidden helpers working behind the scenes. And that leads to a really fascinating question. We use async things like setTimeout or fetch to get data all the time. But where do they actually live? If you cracked open the source code for the V8 JavaScript engine itself, would you find the code for setTimeout in there? And the answer is no. It's pretty mind-blowing, but they are not there. These asynchronous functions we rely on aren't actually part of the core JavaScript language. They are superpowers given to JavaScript by the environment it's running in this case, the web browser. So let's look at the full picture. The runtime environment is way more than just the V8 engine. The browser also gives us a whole set of tools called web APIs. This is where things like the DOM, AJAX, and timers live. It also provides a waiting area called the callback queue. And then there's the coordinator of this whole operation, the event loop. These are JavaScript's hidden teammates. All right, we've met the players. Now let's actually trace the journey of an asynchronous call. We're going to follow our friend's setTimeout and see exactly how this team works together to keep that one-lane highway clear. Okay, so follow along. First, setTimeout gets called. For a brief moment, it's on the call stack. But here's the magic trick. It doesn't stay there. It immediately hands off its work, the timer and the function to run later, to a web API. Then setTimeout is popped right off the stack. The highway is clear again. While that web API is off to the side, running its timer, your other JavaScript code can run just fine. Now, once the timer finishes, the web API doesn't just jam the function back onto the stack. Nope. It places that completed callback function into the callback queue, where it has to wait in line. And this is where our star player, the event loop, comes in. The event loop has a super simple but absolutely critical job. It's like a bouncer at a club. It's constantly looking at the call stack. If the club is empty, and only if the call stack is completely empty, it looks over at the line waiting outside, the callback queue, and says, all right, you're next. It takes the first thing from the queue and pushes it onto the stack to be executed. That's it. That's its entire job. And that one simple rule, that's the secret sauce. That's how our websites and apps stay smooth and responsive. It's how we avoid that giant, frustrating traffic jam on our one-lane highway. Just look at the difference here. On the left, you've got a slow, synchronous loop. It hogs the call stack, the browser is totally stuck, and the UI is frozen solid. But on the right, by using an async pattern, we process one small piece of work and then we let the stack clear. This gives the browser a precious little window to breathe, to handle clicks, to scroll, and most importantly, to actually render updates to the screen. Then the next piece of work can start.
This brings us to probably the single most important rule in front-end development. When you hear a senior dev say, "Don't block the event loop," this is what they're talking about. They mean don't put slow, chunky, synchronous code on the call stack. Because when you do that, you're not just blocking your own code, you're blocking the entire browser from doing its job, which is to create a great experience for your user.
You see, for that smooth 60 frames per second experience we all expect, the browser needs to repaint the screen about every 16 milliseconds. And guess what? A repaint is just another job that has to wait for the call stack to be clear. In fact, rendering usually has a higher priority than our regular callbacks. So if your slow code is blocking the stack for, say, 100 milliseconds, you've just prevented the browser from rendering about 6 frames. That's what we call jank. That's the sluggishness. Okay, let's zoom out one last time and put all these pieces together. If you remember anything from this, remember these key points. Here's the big picture. 1. JavaScript itself has just one call stack. It's single-threaded. 2. The browser is an amazing teammate that gives us web APIs to handle slow tasks in the background. 3. The callback queue is the waiting room for those tasks once they're finished. And 4. The event loop is the simple but essential coordinator that moves things from the waiting room to the main stage, but only when the stage is clear. So, I'll just leave you with this to think about. Now that you really have this mental model of how the browser and the JavaScript engine work together, how is that going to change the way you write your code? When you're building your next feature, will you think a little differently about how you handle big loops or API calls? Hey, if this explainer finally made the event loop click for you, do us a huge favor and smash those like and subscribe buttons. It really helps the channel out. Thanks so much for watching, and we'll see you in the next Build Bytes Daily.